Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 12. This training module, we're going to take a look at programming our throttle body data into our stock calibration files. So if we've changed the throttle body, we need to go and account for that in the Ford programming, or it doesn't understand how to translate airflow into a throttle movement through the torque control tables. So we have to enter in that throttle body data correctly. I'm providing a whole bunch of different throttle body data sets for different throttle bodies we'll find commonly used on the Gen 1 Ford Coyote application. So you can do essentially a simple copy and paste feature into the file, and it'll get you started in your calibration process using that larger throttle body. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at programming our throttle body data in our Ford Gen 1 Coyote applications. Our throttle body data is an essential calibration step that we need to account for if we're installing a larger than stock throttle body size on our engine. So if you're installing, let's say, a Cobra Jet throttle body on your intake manifold and you try to run it without putting the calibration data into the PCM, you're going to run into all kinds of problems. We want to avoid having calibration problems, drive-by-wire control problems. We want to put the calibration data in correctly the first time. We're going to take a look at how to do that in this tutorial, and we're going to discuss how the throttle body model works and how it fits into our airflow model, because it is important, and we can't calibrate things like our speed density unless the throttle body data is spot on. Let's talk about this real quick here. So I have a 2013 Mustang GT file open. I'm going to go in here to Engine tab, and then from Engine, we're going to move from General into Airflow, from Airflow into Electric Throttle. This is going to be all of the data sets in order to program and work with our electric throttle programming control. Now, it looks pretty intimidating. We don't really need to touch much of what we have for data in here. What we're concerned with at this point in time, if we've installed a larger than stock throttle body, is to go in down here under the throttle body model and update our predictive throttle angle and our effective area tables. These are going to be inverses of each other, and they're used in figuring out our drive-by-wire control. It's essentially telling the Ford PCM what type of throttle body you have installed, meaning how large the actual throttle plate is going to be, and then how it's going to expect the throttle plate to open at that specific amount of the effective area in inches squared. So essentially it's going to be taking a look at your effective area of your plate as you're tipping in your foot on the throttle and it's opening that throttle plate. It needs to know that size, that range that it can expect, and that throttle angle it can expect things at, so that it feeds into our drive-by-wire control and also into our airflow modeling. I'll explain that here in just a second. Let's pop into these tables and take a look. So we have our predictive throttle angle and we have our effective area. Let's talk about our predictive table here first. This is going to be a feed forward style table into the closed loop throttle control system in our Ford PCMs. We're going to find here it has our ETC vacuum on our left axis. It's going to have our effective area as our top axis. The effective area in inches squared is translating the throttle plate size into the language that the PCM is going to understand. So at various different effective area ranges of our throttle plate opening, essentially allowing airflow into the engine, it's telling the ECU, the PCM, what to expect for a throttle angle. So the better this table is calibrated, the better our drive-by-wire and throttle control is going to function. Now, this is going to be really specific. We really can't figure out this data and just hand fit the data. We want to go in and use data sets that are available for the throttle plates or throttle body sizes that we're dealing with. And providing that here in the training course is going to cut down on a lot of headaches and setup time. And essentially, you won't be able to start to dial anything in your calibration process. So you can't really dial in your mass airflow, can't really dial in your spark timing or variable cam control until this is programmed right. So we need to get this right, and this is, again, one of these basic details that we need to account for when we're building our calibration file from scratch. So we're going in and programming our MAF curve, programming our injector data, throttle body data will definitely be next if you're changing your throttle body from stock to something else. So this table here is essentially saying at a given effective area, at a given ETC vacuum, or the amount of vacuum passing through the throttle plate, it's going to expect the throttle to be right around this range. This is modeled from Ford, so this data is going to be accurate. Now, this is the main table. We have an inverse table. So what I want you to take note of is take a look here at the effective area, the top axes of the table, the top breakpoints of the table. This is going from 0.01 to 4. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.